and welcome to the practice problems video for the section on addition and subtraction identities. Okay, so number 1 asks us to find an exact value for each of the following. So for this problem, we actually have two parts. Let's do part A first. So A says cosine of 7 pi over 12. So the first thing that comes to mind is, wait, where's that on the unit circle? So the thing is, we can actually just break this up into simple angles. So the first thing I would recommend is probably saying, okay, what can we break up the top into, and just keep the denominator the same for now. So we could break this up into 3 pi over 12 plus a 4 pi over 12, and these are easily reducible into, so we'll get cosine pi over 4 plus a pi over 3, which are definitely angles that we're familiar with at this point. So now we can use the addition identity for cosine in order to break this up into kind of like mini terms. So we're going to say that this is equal to, so this is kind of like our alpha, our first angle, and this is like our beta. So we could say, okay, so we have cosine of pi over 4 times cosine of pi over 3. We need the opposite sign in the middle because we're working with cosine. And then we'll do the same thing. We'll just stick both of these angles into the sine, okay? So we get something like this, and now all we have to do is just use our unit circle and our knowledge to figure out what are the values of each of these mini terms, okay? So here's pi over 4, that's halfway in between, and pi over 3 is this one, like 60 degrees, right? So cosine of pi over 4 is just going to be our normal radical 2 over 2. Cosine of pi over 3, that's our x value, that would be 1/2, a positive 1/2. Minus sine pi over 4, that's also radical 2 over 2. And sine pi over 3 is now going to be radical 3 over 2. Okay? So this just becomes a radical 2 minus a radical 6, and then over 4. Okay, so here's part B. We're just going to solve for sine of 5 pi over 12. So let's do the same thing. We're just going to break this up into, let's see, what should we do? Sine of, we could say the first one is, I don't know, 3 pi over 12 plus 2 pi over 12. Okay, and again, those are easily reducible into sine of pi over 4 and then plus pi over 6, which are both angles that we know of, right? So sine, now we're going to break this up into sine pi over 4. So the first angle times cosine of the second angle. We're going to keep the same sign in the middle because it's sine, same sign, right? And then we have sine, and we're going to switch those angles. So pi over 6 and then cosine of pi over 4. Okay? So now let's just solve for those. Let's use our unit circle. Let me see here. Let me draw one real quick. So pi over 4 is right here, and pi over 6 is over here. Okay? So sine pi over 4, again, is radical 2 over 2. Cosine pi over 6, that's our x value. So that'd be radical 3 over 2. Okay? And then we have plus sine pi over 6, that would be 1/2. And cosine pi over 4 is radical 2 over 2. So we're going to get an answer of radical 6 plus a radical 2, and then all over 4. Alright, here's number 2. We're going to rewrite this cosine of x minus 5 pi over 6 in terms of sine and cosine x. Okay, so we see a difference or a subtraction identity here with cosine. So we're just going to write cosine of x times cosine of the other angle, 5 pi over 6, and then change the sign in the middle, okay, and then we'll put sine of both of these angles, okay, so sine 5 pi over 6. Alrighty, so now we're just gonna, we know this, and we know this as well, so let's just find that on our unit circle first of all. So 5 pi over 6 is almost at 6 pi over 6, which is pi, so 5 pi over 6 is over here. Okay, so we just have cosine x here, and cosine of 5 pi over 6 is almost -1, but not quite, so we have negative radical 3 over 2. Okay, and then we have plus this sine x, and then sine 5 pi over 6 is a positive 1/2. Okay, so let me just rewrite this in a nice form. So we just get negative radical 3 over 2 times cosine x, and then plus 1/2 times sine x. And that's it. We're done because we just wrote that expression in terms of cosine x and sine x.
Rockin' the disco, starting the fight.